Hello everyone, welcome to this session. Our chapter is nonmetals and their compounds. So in a previous video, we saw its introduction. We discussed the various general chemical properties of these nanometals. So today let's move on to the other part, whereby oxidizing properties of the nanometals. So here we'll be seeing this as one of the property of the nanometals. Nanometals simply they react by gaining the electrons to become negative ions. So the nanometals they react simply, or they just combine with other elements by gaining the electrons just to become the negative ions. A univalent nanometal accepts just a single or one electron, while a divalent one just accepts two electrons. So you have to know that there can be two kinds of these nanometals. They can be univalent, which accept a single electron, and they can also be the divalent that can accept two electrons. Now the ion formed carries the corresponding number of the negative charges, but they rarely exceed 2 and never exceed 3. So that's how these ions are formed. They are the ones that carry the corresponding number of the negative charges, as you can see in the examples. Now, uh, let's see, discussing further about these oxidizing properties of the nanometals. Let's see that when a substance loses electrons, simply it becomes oxidized. Now, this means that its oxidation number increases. So this process is what we call the oxidation. So oxidation is that when a substance is when a substance loses the electron, becoming oxidized. So that's what it is, and it means that the oxidation number increases. Now, due to the fact that the nanometals they accept the electrons donated by the other substances, particularly metals, they are therefore termed as the oxidizing agents. So nanometals are the oxidizing agents because due to the fact that they are the ones that accept the electrons that are donated by the other substances, specifically or particularly the metals. Now, this is because by accepting the electrons, so they help oxidize the electron donors. Now, those substances or metals which they donate the electrons are what we call the reducing agents. This is because simply the electrons they reduce the oxidation number of the nanometals. Now, this process. Now, in this respect, the nanometals, they simply act as the oxidizing agents, while the metals, they act as the reducing agents. I hope that's clear. Now, let's see the strong and the weak oxidants. As we have already seen in the oxidation properties. So let's see that in this case, the extra electrons, they accepted, they lead to the formation of the negative ions, the ability of an element to accept the electrons. So the easiness of just forming or just the formation of these negative ions will just depend, or will really focus on the ability of an element to accept the electrons. The ability of accepting the electrons is what we call the electronegativity of an element. So some elements they are more electronegative than others. Simply we're talking about some they are quickly, or they are more accepting electrons than the others. Now, the order of the electronegativity of some nanometals is as follows, starting from the first one to the last, meaning that the first one is more electronegative than the others, starting with the fluorine, then it becomes chlorine, then bromine, then iodine, nitrogen, and carbon. Now, in this list, you see that fluorine the most electronegative, and the carbon is the least electronegative. The degree of this electronegativity just indicates the reactivity and hence the oxidizing power of the given element. Elements with the higher electronegativity will displace those elements with the lower electronegativity from their compounds, as from that list of these electronegative elements. Now, referring to the series above, which you've seen, fluorine will displace all the rest of the elements as it is the first one from their compounds, as it is more electronegative than any other elements in the series. Likewise, the chlorine can displace the bromine, iodine, and the nitrogen from their compounds. Now, the displacement reaction, it occurs in this manner, as you can see here, the two of the elements, the one with more electronegativity will replace the one with the less electronegativity. Now, where X is more electronegative than the Y, as we've seen. Now, take an example. Here we have chlorine plus the potassium bromine. So, the chlorine will replace the bromine, so we need to put the potassium chloride plus the bromine gas. I mean the bromine. Then also leads to this other example: chlorine plus the potassium iodine. The chlorine will replace the iodine, and then leads to the potassium chloride plus the iodine. I hope that's clear. Now, the higher the electronegativity, the stronger the oxidant. So the higher the electronegativity of the given element, the stronger the oxidant. For example, bromine is stronger oxidant than iodine, nitrogen, and the carbon. So that's all I have for this session of task clear. We've seen the oxidizing properties of these nanometals, and we've seen the strong and the weak oxidant based on the electronegativity series of task clear. And thank you.